Hi, my name is Trevor Saunders. I'm the lecture portion for the C programming for electrical engineers. And I'm going to go over my pseudocode and my project, the array maze. Just real quick, this is the first step. You're going to be prompted to have the entrance and exit cells, so you're going to know where to start, you're going to know where to end, and that's going to tell you if you're done or you're not done in your maze if you have a loop. This part is redundant here, actually. I'll mention it, though, because a professor said we did not, if we wanted to fix our code for something that was redundant, we didn't have to. So initially I wanted to set the perimeter for fives, so just, if you're going out of bounds or not. But I did something a little different, actually. I didn't make a perimeter of fives. I had some other conditions where if you're leaving the boundaries. This is kind of the backtracking right here. If you're gonna have your standard move set, I'll mention this first. There's our standard move set for our user-defined functions. You're gonna go down right. Sorry, you're gonna go down. You're gonna go right. You're gonna go left. You're gonna go up. And if you can't make all those, you're going to go back to the initial cell, and you're going to mark that one as a 5 because you can't go anywhere, so you don't want to go back. It's going to be a dead end. So if you start over here, you can't make a down, can't make a right, can't make a left. You're going to go back up. You're going to mark this as a 5, and it's going to happen right up here. And for the boundary conditions, you'll be able to go up. You won't be able to exit through the entrance point, come back down, and you'll make a right, and you'll be able to leave. This is just mentioning how I'm going to move up and down. This is an array for the rows, so if you want to add one, so if you want to go down, you're going to add 1, and if you want to go up, you are going to subtract 1, because that's the columns. Add 1 down, subtract 1, you're going to go back up. Same with the columns, actually. Sorry, the X moves is for the rows. The Y moves are for the columns right here. If you want to add 1, you're going to go right on the columns. You want to subtract 1 for the Y move, you're going to go left in the column. So X moves are the rows. You're going to go down, you're going to add 1, you're going to subtract 1 if you want to go up. This is just mentioning how I'm going to mark junctions and print them at the end to show you the final path taken. And this is just mentioning how you're going to do backtracking as well. Really, you're going to go back down, and you're going to mark them as 1s to know that you've been there, and you're going to go back up. Just one last iteration of backtracking, really all the conditions that can happen. If you're going to go in a loop, you want to get back out, so you're going to go in here. You realize, oh, I've already been here, so I'm going to go back out. You're going to mark them all as 5s. And the final thing is just to let you know, print the final maze that you've completed, and let the user know that they finished. So this is the code portion right here. I started out with some global variables. This is my row, my column. I'm actually getting file input for the mazes. So I have the maze in a text file to my right over here, and that's what that's going to retrieve our mazes from. Our global variables, I have a solution array, and I have a original array. So this is our array, and this is going to be the one that's going to print all the moves. So I'm going to make the iterations on this array right here, but I'm actually going to print everything from this array once I make the moves. This is the first user-defined function I have. This is just going to print the solution array that I have right here. That's what this function does right here. It just prints the solution array whenever I recall it. All right, we're going to go to the biggest user-defined function. I think this is the only other one I have, but this is integer solve maze. This is how I make the moves. If I go down, right, left, go back up, or if I backtrack. All the variables I'm doing, this is where I'm starting, ending. Yeah, that's how I'm going to communicate those variables. This is our X position. It's going to start at our starting point. These are our backtracking variables right here. If we come to a dead end, we want to be able to go back. So these variables are what we're going to use as our marks. We're going to kind of leave crumbs until we find conditions that let us come back. And this is just following that. This is our previous steps right here, and these are our temporary steps that we're going to take. Okay, this is going to tell us that we're going to mark everything with 1s, everything that we've taken, all our positions. Okay, So what this while loop says right here, while your x position is not at your ending position, while your x position is not your ending x ending position, and your y position is not at your ending y position, you're going to make all these moves. So if this condition isn't satisfied, this bulk right here is going to keep happening right here. I'll just explain one because they kind of just reiterate themselves over and over. The first one happens right here. This is our down movement, and it works like this. If the maze is a 5, and if the maze is out of bounds because we're going down, we can't go more than the row allows us, well, we're not going to go. So we can't let this happen, and we can't let this happen. If those conditions are satisfied, we're going to move. So if there's a 0 or anything else besides a 5, all this stuff's going to happen. What first is going to happen is we're going to print our move. So we mark a 1 if we move there. And we're also going to mark our steps with crumbs. These are our previous steps in case we want to come back. They're going to move with by integer to integer. And this portion right here, this is what I use to print my maze. I had problems kind of seeing how many steps I was taking, so I printed the maze with every step I was taking. And I just use the continue function just to continue right back up here. If this iteration is okay, so it's going to go continue right back to the while loop and start over again. Continue over here. If this is not satisfied, it's going to go to this one. If this is not satisfied, it's going to go to this one. If that one's not satisfied and this one's not satisfied, this is our backtracking right here. We're going to move, we're going to mark our current position that we couldn't go down, right, left, or back up. We're going to mark it as a 5. Okay, this is just saying if our x position is at our ending x position and our y position is at our ending y position, we're going to print this saying, yeah, Mario has been rescued. Now the main function, how everything works. We're recalling all the mazes from a file. This file is listed right here, 120 rows and has 22 columns. We're opening this total maze that is listed right here, and we're reading all the rows. We're going to start from the counter from 0, going to row 120, and we're going to start from column 0. We're going to column to 220. I'm sorry, 22. And we're going to scan all this and put it into our global variable, our maze right here. Just prompting, I'll go over this when I run the function, but I'm just prompting it gets you all the information. This portion right here is how we actually decide what chunk out of this huge text file that we want to use. So, okay, yeah, so if maze number, if the number you prompted in for what maze you want to solve, if it's number 1, you're going to have row 0 through 19. And you're going to have the same column. So if it's the maze 2, you're going to have row 20 to 39, and so on and so on. Okay. Right here. I'm actually just saying that our maze that we chose is going to be the same as our solution maze. So we have initial array that we're taking out of this, and we're marking it on our solutions. We're making the iterations, all the moves on this, and we're marking the moves to this solution right here. And I'm just printing solutions. If solve maze satisfied, we're going to print the final solution. If it's not, we're going to say there's no solution found. So I know I'm going over time, but I'm going to run this code real quick and show how it works. Okay, if you want to do maze 1, type 1. Row 0, column 9, row 19 is the ending, column 12 is the ending. Now, this is what I have for the problems. These are all my mazes. This is maze 1. I'll show you that I can bring up 1 through 6. And I have it printing every step right here because I had some problems because it stops. I'm going to go down, I'm going to go down, down, and then you make a right. Before finally, it just decides that it can't win and it stops. I believe what the problem actually is it comes down to that it's being satisfied by this condition only. This column is the ending y position that it's okay with. It's like, okay, I got to the ending y column, so that's good enough for me. I'll show you again right over here. This is, let's say we bring up maze 6. That's going to be row 2. 0, 19, 16. This is my maze. It is not being attempted, but I was able to retrieve it from the file. Okay. Yeah. Everything, just potential problems with my mazes right here. I can get it to solve itself, but it kind of cheats and goes through walls. I don't really want to get into that, but that's my maze. That's my code explained right here. All right. Thank you.